we've always built monuments. For generations, a 93-meter-tall copper icon like the Statue of Liberty defined the upper limits of how we commemorated our history. But over the last few decades, that ceiling has shattered. Far outside the world's major urban centers, a new class of monolithic structures is rising. This chart tracks the absolute height of monumental statues over time. On the far left, the Statue of Liberty held the record for over a century. But look at the exponential growth on the right. We have moved from 90-meter GIFs to 200-meter feats of engineering, with modern budgets frequently clearing hundreds of millions of dollars. This raises a practical question for anyone interested in visiting these sites. How do you separate sheer physical size from actual cultural relevance and successful construction? To figure that out, we need to analyze the real-world trade-offs of these massive projects. We'll look at accessible legacy icons, the highly complex modular megastructures, and the ambitious, often unfinished titans. Ultimately, understanding these giants requires weighing the enormous logistical friction of building them against the real cultural and tourism value they generate once the scaffolding comes down. We start with the legacy icons. These are structures that prioritize deep symbolic integration over raw, record-breaking height. During the late 19th century, achieving even 93 meters required intense manual labor, as seen here in the Parisian wooden scaffolding surrounding the Statue of Liberty. Without modern cranes, construction was severely constrained. The monument had to be built in individual component pieces, fully disassembled, shipped across the Atlantic aboard steamboats, and reassembled on site. High urban integration guarantees heavy foot traffic, but it also exposes the monuments to shifting political landscapes. At 102 meters, the Mother Ukraine Monument towers over Kyiv. Built in 1979 for Soviet victory, Ukraine physically modified it in 2023. They removed the Soviet emblem from the shield, replacing it with the Ukrainian coat of arms. You can see this tight urban integration with Japan's 100 meters Sendai Daikonon, framed right alongside daily city infrastructure. This level of immediate accessibility is rare for the sprawling, remote megaprojects being built today. Legacy icons trade record-breaking height for accessibility and historical context. However, their highly visible nature makes them primary targets for revision as national identities evolve over time. Pushing past the 120-meter mark required new engineering methods. To bypass historical height limits, builders adopted the curtain wall method. This involves erecting a rigid iron and steel column, then enclosing it with hundreds of pre-assembled component blocks. Japan's 120-meter Ushku Daikonon demonstrates how this works. By utilizing lightweight bronze-plated sheets attached to the frame, engineers reduce the overall load, allowing the structure to safely stretch vertically. But modularity creates immense supply chain complexity. Indonesia's 122-meter Garuda Wismu Kencana required over 700 individual modules to be fabricated 800 kilometers away. Once they arrived, they were too heavy for the cranes and had to be cut into 1,500 smaller pieces just to be lifted. That massive industrial footprint naturally generates friction. The influx of cranes and heavy transport led local religious leaders to argue that the construction threatened the spiritual balance of the entire island. While modular assembly allows engineers to construct at extreme altitudes, it forces project managers to navigate fractured supply chains and significant local resistance. To reach 200 meters and beyond, projects rely on heavy financial investment. China's Spring Temple Buddha stands at 208 meters and used 100 kilograms of real gold for its exterior finish. By the time it was completed in 2008, the cost hit $140 million, nearly triple the initial estimate. These giants use high-density, brute force reinforcement. A massive concrete core is wrapped in a steel framework, surrounded by a second layer of molded concrete, and finally coated in heavy metals like copper and zinc. You can see this material method at work in India's 112-meter Statue of Belief. The extreme layering ensures structural stability for the seated figure against intense environmental pressures. The limit of this capital-heavy approach is the Statue of Unity, depicting Vallabhbhai Patel, an instrumental figure in India's independence movement. Despite its 240-meter height, this project was completed in just 5 years. The build was aided by a nationwide movement that collected farming equipment from donors to be repurposed into the iron framework. Securing the vast land needed for these deep foundations often forces projects into remote areas. The 129-meter Laykyun Sekkya in Myanmar sits in such an isolated location that it drastically chokes off potential foot traffic and tourism returns. Capital titans deliver maximum scale and physical stability, but they require the observer to accept severe travel friction just to stand at their feet. Some projects capture headlines but fail to capture ground. The Shiv Smarak was designed to reach 212 meters, situated on its own man-made island off the coast of Mumbai. The plans included museums and a direct connection to the city's metro system. The original completion deadline was 2021. Today, long past an extended 2022 deadline, there has been zero physical progress on the site. When projects chase extreme scale, budgets often collapse under the weight of the ambition. But these proposed record breakers generate massive early hype, only to remain entirely theoretical years after their deadlines pass. The same pattern applies to the proposed 252-meter statue of Lord Rama. Outside of initial soil testing back in 2018, the monument has seen no physical construction. If your goal is to seek out record-breaking height, the most significant risk is investing your attention into a project that never actually moves past the rendering phase. Looking at the data, raw scale does not correlate with success. Massive budgets do not guarantee accessibility or cultural impact. This chart maps travel friction against cultural and spectacle ROI. It provides a way to evaluate which of these projects actually align with your priorities. Legacy structures like the Statue of Liberty and Mother Ukraine sit in the top left. They deliver high cultural returns with low travel friction due to their urban integration. The massive completed titans occupy the top right. Seeing the Statue of Unity offers undeniable engineering spectacle, but you will pay for it through extensive travel times to remote locations. The theoretical builds sit in the bottom right. They generate high speculation, but currently deliver zero real-world impact. Choosing the right site means deciding whether you value immediate historical context or if you are willing to endure the logistical friction required to see a modern giant. If you want accessibility and a narrative that connects directly to a city, prioritize legacy structures under 110 meters. The history is richer, and you won't need to charter transport into the wilderness to experience it. But if you want to understand the limits of modern construction, the 200-meter completed titans are your target. You will spend days traveling to remote sites, but the physical scale is unmatched. Be skeptical of any project over 210 meters. Until heavy cranes move physical steel, those record-breaking numbers exist only as blueprints and soil tests. A monument's success depends on more than a multi-million-dollar budget. It requires the logistical follow-through to turn a massive height into a completed, accessible destination.